numbers is what we did, and we talked about taking I to a super high power, and we simplified high powers of I, and then we did basic addition and multiplication. And now, for this, iteration is the process of repeatedly applying a function to the output produced by the previous input. Ugh, that is a lot of word jumble. When using complex numbers with functions, it is traditional to use z for the independent variable. So essentially what this is saying is you plug in a value, and then whatever value you get out, you plug back into it, and you keep doing that. So here we have if f of z equals 0.5 plus 0.5i times z, find the first 5 iterates of f for the initial value z sub 0 equals, or z naught equals 1 plus I. So our initial one, we're plugging in f of z naught, which is 1 plus I, so we get 0.5 plus 0.5 I, and then we multiply that by 1 plus I. And so what that's going to get us is we're going to get 0.5, right? So 0.5, and then we're going to get a 0.5 I and a 0.5 I, which together is just I, and then a 0.5 I squared. And I squared is really just going to make that negative, right? So really just a minus 0.5. So positive 0.5 and minus 0.5 are going to cancel, and we just get I. So now, that was our first one. Now we plug in f of I. And so that's going to get us 0.5 plus 0.5 I times, and now what we're putting in for z is I, right? And so we get 0.5 I, right? And then we're going to get 0.5 I squared, which is minus 0.5. Right? Now, we're going to plug, this is what we got, so now we're going to plug that in, 0.5 I minus 0.5. And usually we write the I on the other side, but actually I will do that here. Usually we put our real part first, and then our imaginary part over here. So now we're going to do 0.5 plus 0.5 I times z, which is now negative 0.5 plus 0.5 I, which is going to get us, this is actually a difference of squares, but I will do the multiplication out anyway. This would be negative 0.25 plus 0.25 I, right, plus or minus 0.25 I, which is going to cancel, and then the last one is going to be plus 0.25 I squared, which I squared is just minus, and so we have minus 0.25 and minus 0.25, or minus 0.5. And now we plug in, I know it's a little annoying, negative 0.5, and we get 0.5 plus 0.5 I times negative 0.5, and we just keep going, right? That'll be negative 0.25 plus or minus minus 0.25i. And how many have we done? We've done 1, 2, 3, 4. Let's do one more. All right, so if we do f of negative 0.25 minus, converting plus, minus 0.25i, then that is 0.5 plus 0.5i times negative 0.25 minus 0.25 I. Right, and then you would just keep going and going, and the pattern is that we kind of keep trading and halving, right, what we're doing. So we go from a whole 1 down to 0.5, and then down to 0.25, and then we'll go down to 175, and we would keep going. And that's kind of the pattern there. Now, what I wanted to show you guys is you might be like, hey, what's the point in iterations? Well, iterations or like in complex numbers, you might say, okay, plugging this back in over and over is kind of boring. What's the point? Iterations have to do with things that happen over and over constantly and are changing constantly. And there's a couple big things that iterations are used for, and one is the stock market, right? You can make predictive math models out of iterations, right? Because that's really what a stock market is. It's iterating things over and over. It's doing something over and over, right? And you constantly just keep plugging it back in and seeing what you get. And then there's a little revelation I had. So, keep in mind, we are working with polar coordinates right now, right? And then we kind of just switched to doing imaginary numbers. And there is this connection between them, which is kind of why we're going over them in the same chapter. And, I saw that we were talking a little bit about iterations. And then I had the idea that I remember back in college, I was looking at something called the Mandelbrot set, which is some super fancy thing. And so, due to this unit, we should know what this is, right? This is a little cardioid. This is one of our standard polar graphs, or our classical curves, as we call them, right? This cardioid. And then I was thinking back to the Mandelbrot set, and I was like, hey, isn't the Mandelbrot set an iteration in the complex plane? And it sure is. And if I look up Mandelbrot set right now, we're going to see something kind of cool. Look at that. What does that look like? Oh, that looks like a cardioid, doesn't it? And this is an iteration of doing this equation over and over on the complex numbers. And the Mandelbrot set is really cool. It's fractal. It goes in forever. So if we look at this zooming in forever, this is a set of numbers graphed out, and it looks like this. It's kind of crazy. So yeah, I just remember that. So there's that connection between iterations and polar graphs and polar coordinates, right? So I wanted to show you guys that. So those are the iterations. And now for these, two complex numbers of the form a plus bi and a minus bi are called complex conjugates. You guys should have heard the word conjugate before. You might just not remember exactly what it means. But in order to simplify when dividing by a complex number, you should multiply the numerator and denominator by the complex conjugate of the denominator. So it's very similar to how you would rationalize something like 1 over 3 plus the square root of 2. Remember, we're not cavemen, so we rationalize. So to do this, we would multiply the top by 3 minus the square root of 2 and the bottom by 3 minus the square root of 2. It's the same thing with complex numbers. So if I have 5 minus 3i divided by 1 minus 2i, to get rid of the I in the bottom there, I'm going to multiply by the conjugate, which is going to be 1 plus 2i. And you'll see why. It's because this pattern happens where You might want to think of parentheses on all of these. Right, so here we're going to get, on the top, we're going to get 5, and then we're going to get minus 3i plus 10i, so plus 7i, right? And then we're going to get minus 6i squared, right? All over 1 times 1 is 1. We're going to get minus 2i and plus 2i, which is going to cancel out. That's the whole point. And then we're going to get a minus 4i squared. And now we can simplify that. I squared is just negative 1, so really we're going to be adding this 6. So 5 plus 6 is 11 plus 7i all over. And then again down here, this is really going to be plus 4 because I squared is negative 1. 1 plus 4 is 5. So you could write it like that, or you can write it like 11/5 plus 7/5 I, however you want to. I'm okay with either of these. Right. This one is probably more how that's more like an a plus b times I form, right? A is 11/5, b is 7/5 times I. So this is probably how you want to leave it. But all right.